This is problem number 3 from section 1.3. In this problem it says the value of sine x is given. Find tan x and cosine x if x lies in the specified interval. They give us sine x equals 5 over 13. They say that x is lying in the first quadrant, which would be 0 to pi over 2. So let's draw a triangle in the first quadrant. I draw the triangle in the first quadrant. This is theta. We don't know what theta is. Or in our case, this would be x, how they have it written, right? Sine x. Now we know sine is opposite over hypotenuse, so this is going to be 5 over 13. Because we're in the first quadrant, we know that sine is going to be positive, and so will cosine. We need to find this part right here. We're going to use the Pythagorean theorem. So we're going to say a squared plus b squared equals c squared. In our case, that would be, we're going to call this the a squared, this is the b, so we'll say this is a, b, c. So this is a squared plus 5 squared equals 13 squared. So a squared plus 25 equals 169. Subtract the 25, we get a squared equals 144, and we take the square root of that, and that's going to be a equals 12. So this is 12 right here. So that means that tan x, we know tan x is the opposite over adjacent, which means that we have 5 over 12. Opposite over the adjacent. And then we know that cosine x is the adjacent over the hypotenuse. Adjacent side's 12, hypotenuse is 13, so we get 12 over 13 for the solution there.